Okay, welcome back to our tech share. This is our fourth session for the day and our final session. And we're privileged to sit down with August Saggianto, who is Executive Vice President and Head of Corporate Model Risk for Wells Fargo. And we're going to discuss Interpretable Machine Learning. A little bit about August. He's Executive Vice President and Head of Model Risk and a member of the Management Committee at Wells Fargo, where he is responsible for enterprise model risk management. Prior to his current position, August was the Modeling and Analytics Director and Chief Model Risk Officer at Lloyd's Banking Group in the United Kingdom. Before joining Lloyd's, he is an executive and head of quantitative risk at Bank of America. Prior to his career in banking, he was a product designer manager in the powertrain division of Ford Motor Company. August holds several U.S. patents in both finance and engineering. He has published numerous technical papers and is a co-author of design and modeling for computer experiments. His expertise and interests include quantitative risk, particularly credit risk modeling, machine learning, and computational statistics. He holds a master's and doctorate degree in engineering and management from Wayne State University and the Massachusetts and MIT. So welcome, August. We are very interested to learn more about interpretable machine learning, and I will turn the time over to you to get started.
Thank you so much. Thank you, Steve. So what I would like to do today is to share our view and our need in highly regulated industry where we apply model for various purposes. We have a few thousand model in our inventory that we run day in and day out to do many, many things in the bank. Banks basically run by model. And we are in the environment, in our case, really a lot of our application, what we call it as high-risk application. They have significant impact where that if the model are wrong, including model that can impact our customer as well. Part of this discussion, I'm going to share with you our approach in the using interpretable machine learning and how to test machine learning for real production in high-risk environment. We have a tool that we publish out there. It has in GitHub. So if you, it's called PiML, Python Interpretable Machine Learning. If you Google PiML toolbox, it should take you to the GitHub page where you can download the tool, you can try the tool. It has a lot of material that we presented through workshop, etc. So that's what I am going to share with you today. So let's see if I can successfully control. Okay. So I talk about model risk. We believe that all model that all model are wrong, and when they are wrong, they create harm or unintended consequence. They harm either the institution, the model user, or the customer. In banking, we use for financial model. Financial model will create financial harm, be it credit loss or market loss or liquidity problem. And this is the example in the crisis of 2008. It was a model that's really problematic and create all those financial harm that all of you that's old enough experience that. But also non-financial harm that create reputation, compliance, or legal, particularly when our model are discriminatory to protected class, so they can violate law or legal requirement. So we care a lot about what can go wrong with models. So we have a very, very rigorous process how to prevent and how to manage that. But let me give you a quick example in terms of the situation. We have model, we all develop model and we deploy model. The environment that the model deploy are very dynamic. So the development environment is not the same as deployment environment. The data that use for model development have different distribution of the data that is in the deployment. So input can shift and drift, concept can shift and drift as well. So the best model that develop can be the worst model when we deploy it. So a few questions on this then, can we rely on AutoML or frequent retraining is the answer because the environment changed. I would say both of them are, the answer to both of them are no, but let's go to a few examples and then how the tool that that I'm going to share with you try to address this. So this is the problem that is in machine learning. Machine learning are models that overly parameterized, have a million parameters, can be depending on the size of the model. So in machine learning, we have a phenomena that we call multiplicity. Various model, very different model can have similar performance. The Rashomon effect, some people call it Rashomon effect. I think the great Leo Breiman, the inventor of random forest, call it Rashomon effects. Basically, model can have very similar output, yet they are very, very different model. And the problem in machine learning as well, what we call it as benign overfitting. A model that the model overfit, all machine learning model overfit basically, but the overfitting doesn't show up. The steep bias variant trade-off in traditional model doesn't show in machine learning. The more complex model can be still perform very well. So I give an example on the right-hand side here. As the model more complex, the horizontal line is complexity of model. And if it's gradient boosting machine, that's really the depth of tree and the number of boosting. If it's deep learning, is the number of nodes in a hidden layer and the number of layer. So the more complex model, the model can fit better and better. In fact, it can be also zero error. And surprisingly also, on the testing, the more complex model, you don't see any overfitting or very, very minimum. Now, the problem is we have a lot of model, very, very different model. And which one do we want to choose? And is this benign overfitting is not real problem. This benign overfitting, it turned out when during model deployment, the distribution change, data drift, it has the input distribution drift. This benign overfitting actually becoming harmful. This is why it's very common that when you develop model, then you deploy, the performance is degrading very, very fast. This is a very, very common problem in machine learning. The performance in real world is way off from the performance during development because of this benign overfitting problem. When we do model development, we simply split training and testing data. Testing data, because we split randomly, it will come from the same distribution of training data. Those we will not detect any overfitting. Only when distribution drift during the model use, then you start seeing very dramatic model degradation. So this is the problem with machine learning robustness and reliability that we care a lot in high-risk environment. We want to build model that is really robust so that when we have distribution drift, the model will still perform as best as we can. So that's one of the key. The other thing is unsound model because of the multiplicity. Some of the model doesn't make sense, actually. If we understand the input and output relationship, they don't make sense. Yet they can still have very good performance as well. So dealing with that, model explainability is very, very important. The field of XAI, explainable AI, is dedicated to that, to come up with techniques that can open up a black box. But those XAI techniques what we call it as post-hoc explainer can be easily wrong. So with that, we in high-risk environment, we use what we call it inherently interpretable model. Still very, very complex model, still deep learning, still gradient boosting machine, but they are inherently interpretable because we control the architecture. So we're going to do that a little bit. I spoke about robustness of the model. So judging model, like the practice in AutoML, based on simple performance, AUC, accuracy, or MSE, that's clearly not sufficient for real world. So we have to test model beyond simple accuracy. We have to understand overfitting. We have to understand model robustness. We have to understand model reliability and resiliency. So with that, this is what the key component in what we call model validation. When we test model, we look at the conceptual soundness and we look at the outcome analysis. Conceptual soundness, we're looking at the overfitting, causality, explainability, interpretability. So I'm making distinction between explainability and interpretability here. Explainability is really using post-hoc explainability. Interpretability is really building model that inherently interpretable. And then in the outcome analysis, we're testing for error analysis, understanding the weak spots with area that model is weak. We testing for reliability. How reliable is the of the prediction? What is the confidence on that prediction? Point that the prediction interval is wide, it's less reliable. So we would like to be able to build model that the prediction interval, the uncertainty is narrow. So that's testing for reliability is important. Bias and fairness is the model is fair, not discriminatory. To protect this class is very important. Robustness is very critical for us because when model is deployed, it's subjected to noise in the input. So we need to make sure that model is not sensitive to any noise in the input. Model will still perform very well. And then we talk about resiliency, basically data drift, big distribution drift, whether the model will still perform or not. So this is all the functionality that we put in PiML. The causality and fairness will be in the release 0.4, which is end of the month. So what's for that? So what PiML does is basically have two functionality. One is model building, how to build model that inherently interpretable, and then the model diagnostic that talk about reliability, robustness, resiliency, and so on. So visit the GitHub and look at what's in there. Let me go a little bit on the interpretable model, then we can open it up for question and answer. When we talk about explainable machine learning, we talk about two streams. One is designing and building model that inherently interpretable, and the other one is black box model, and we apply post-hoc explainability. When people talk about XAI today as the bottom, the post-hoc explainability, black box model, we apply post-hoc explainability, and we'll talk about what's the problem with that approach. On the other stream is really, let's build sophisticated model, still gradient boosting machine, deep neural network, but we're going to make it inherently interpretable. So we do not need post-hoc explainability. And I'll share with you a little bit the problem. Here is an example of post-hoc explainer. Can we trust post-hoc explainer? People use a lot of Lime, SHAP, and all kind of those with faith today, without proof that those technique really works. Unfortunately, the more complex the model, those technique, most of the time, they don't really work. So I give an example here using PiML, so you can test this yourself, experience yourself when you use PiML, and open it up. And test it using data. There's also some example in PiML. So here is an example. Let me pick SHAP because SHAP is the most popular, and then with ReLU DNN. ReLU DNN, we can make it inherently interpretable locally because ReLU DNN let me see, ReLU DNN is basically is a ReLU basis function, basically piecewise linear. So for every point that you fit into ReLU deep neural network, it degenerate into local linear model. We can get exact local linear model. So this is only for ReLU activation function. You cannot do it for any other activation function. For ReLU activation function, for piecewise linear activation function, you can get exact local linear model. Because you have exact local linear model, just like regression, you have the coefficient. You have exact. And here's one example that I have. This is you can try yourself using PiML. In this case, for this data point, latitude and longitude is the most important. This is California house price data, and the actual model is actually longitude and medium income as the most important variable. So post-hoc explainability tool can be wrong. So that's why in our case, we really look at more on the inherently interpretable model for high-risk application. Here is an example of inherently interpretable model. You can read our publication in pattern recognition on this. You can visit the GitHub to get all of this as well. What's in inherently interpretable model is basically we control it so that we have each individual variable, we feed it into network. If you use gradient boosting machine, you can feed it into gradient boosting machine, or two variable that it enter into a network. So you can see the effect of individual variable very clearly because you can plot it, or you can see the effect of interaction very, very clearly and exactly. So you have the real inherently interpretable model by design. So we're using deep learning or gradient boosting machine in a way that's inherently interpretable. Here is an example of robustness. So I want to leave it more 10 minutes for Q&A. Here is an example why robustness is important and why AutoML is no good. So if this is an example, I'm running XGBoost, ReLU DNN, and ReLU DNN. There's a lot simplified ReLU DNN, less number of nodes, less number of layer, basically. The way we do it by applying L1 penalty. You can do this one in PiML to get all this model. So I run XGBoost on this, comparing those three. So the one in the 0, here, basically I split the split the data into training and testing. And I evaluate the model based on testing data. You look at it based on testing data, XGBoost is the best because this is MSE, so the smaller the better. But what happened when in production, the input data has different noise. So you see here with very small noise perturbation, 1% standard deviation, XGBoost performance degrades very, very quickly, where the ReLU DNN, the more simplified model that performed the worst under testing data, it performed best in the deployment because it's robust against noise. The degradation is much less. So the bigger the noise, the performance still stand, while XGBoost, the performance degrade very, very rapidly. This illustrates that model that you choose or model that chosen by AutoML based on testing data can be the worst model when you put it in production. So all this evaluation is done in PiML. That's why in PiML it has this robustness testing to make sure we can compare model and choose model that will be robust in production. Same thing when we have big, that's robustness is small perturbation, small noise. How about if we have big distribution drift? So we can look at it as well, how the performance degrade with the big performance drift when the distribution of the training different from distribution when the model is used. And we can also see what variable that is the drift that will make that the model is very sensitive about. So all this functionality, I just give a few examples of functionality in PiML to really test model, to how to build model that inherently interpretable, also how to test model that will be robust and reliable in production. So with that, Steve, I'm going to open it up for Q&A.
Thank you, August, for sharing that. If anyone has any questions, please post those in the comment section. August, what's the level of support is Wells Fargo providing for training, or if they have questions or features? How can someone reach out at this point,
right,
as they want to use this?
Yes, we have a dedicated team, our PiML team, that support this. So the best thing to reach out is go to the GitHub. It has comments. It has comments in there, so you can reach out people through the GitHub. Put the question in there, and we provide the team regularly run workshop. And also, if you have any question on the tool, you can do it there as well. So we run workshop very frequently. Actually, in the GitHub page, if you look at under documentation, it has a few workshop material, a lot more detail training material than what I spoke about, covering all aspects, all the functionality in PiML.
Sounds good. And what we'll do also, for the texture community, we'll be advertising that workshops and more about the PiML GitHub account. So we have one question that came in from Brian. It looks like a valuable tool. What would you say are some of the strong and weak points in the current capabilities you have today, and what's coming in the roadmap?
Yes, the strength here are really, you have the functionality. If you look at it today, a building model that inherently interpretable instead of using black box with post-hoc explainability. So this is the tool that we put in PiML. We only put a few tools today. This is a growing tool. So in fact, the version of 0.4 will have a new additional techniques that will be in there. So we're still growing. We're trying to put more and more tools. So building inherently interpretable model is there. You can test post-hoc explainability to the truth, to the ground truth, because you have inherently interpretable model, so you can experience yourself whether you trust Lime or Lime and Sharp. So this is the first tool that enabled that. Secondly, tool that provide you with robust and reliable model that will work under changing environment. So very upfront during model development, we can see how the model will perform. Typically, people will throw it out there and then monitor it, the performance of the model will degrade. Here, we can build model that will be robust upfront, testing and anticipating how the model will degrade. And what variable that we need to monitor so that because that's probably more sensitive to distribution drift. People do it today through a lot of observability tool, model monitoring. We try to bring this one up front during model development, that we can really very sure when we deploy model, we have high confidence. So that's what we have. More functionality. I talk about a few things that I mentioned before. The fairness functionality will be released in 0.4, which is end of the month. So you will have with that. And then additional thing is what's important as well is causality, because people today build model really based on correlation, not causal input. So PiML 0.4 will have causality tests where you can test whether the input is causal to the output or not. Through model selection, not only doing statistical correlation, but really based on causality testing. So that will come up in 0.4. The tool is growing. So what's for the update and contribution, if people want to contribute, want to add functionality in PiML, we open to that as well for collaboration, for people to contribute to PiML. So we want to put it out there here, tool that is really for real world application in high-risk environment.
No, we appreciate that, and we support your efforts for those other financial institutions that are thinking about open sourcing different components or teams that are doing that, any best practices you like to share with them? You've ventured in to take this tool that's been useful internally. You're open sourcing it. I'm sure we've had a lot of work internally to do that, and you're trying to build a community around it. And we see, August, your passion for it. So any feedback you have for people that are trying to do the same, or starting their journey?
Yeah, I think it's really different from organization to organization, and it requires guts by the leader to do this, right? So financial model, in particular for credit decision, for example, it's very critical. It's deciding the livelihood of people. If model is discriminatory, model is not explainable and create damage, create harm, that can really decide person's socioeconomics of the future. Not only their future, but can be also their future generation. If we do through models systemically here, it can impact the society too. So we try to do the right things here. I think the financial institution need to have a lot of responsibility of this. Particularly, we are adopting machine learning. So this our motivation really to put this out there so people develop machine learning, deploy machine learning responsibly. So that's what a call that I made here. We do training to several of our peers, other smaller financial institutions that don't have as a resource like us. We help them as well. So we provided training to some of the medium-sized bank or smaller bank that want to use the tool as well.
Very good. And August will be a proponent of that within our network to enable you for that mission, because you have a solid mission to go after. We have 3 minutes here. There's one question by Brandon. Do you have any thoughts about ways we can prevent human bias from interfering when training models and trying to automate? Example, a developer might make decisions about what data should be excluded when cleaning data before incorporating it into the model.
Yeah, I think the having human in the loop is very, very important. We start with, are we going to use certain variable or not? That is very, very important, because certain variable will make model more discriminatory, etc. Actually, in PiML 0.4, it will have this testing which variable that we should exclude to make model less biased. So that will be included in the 0.4. It's very important to have human in the loop looking at the choice of architecture. It's very, very important, because choice of architecture, I talked about model multiplicity at the beginning. So model that have similar performance in terms of, let's say, AUC, can have very different in terms of fairness metrics. So we need to choose model, not only but just based on single performance metrics, but we also need to think about robustness, reliability, fairness, and so on and so forth. So that's what we're trying to do. So if Brandon have more ideas after you look at the PiML, you have more idea, you want to collaborate, or you want to give recommendation to us, we'll be very open. How can we make this one better?
Sounds good. And what we'll do with that one is we're going to be posting this recording on TechShares.com, on Open Teams, posting on YouTube, social media, and then we'll send out email. And if there's ability to work together with August questions, we'll be able to help facilitate that as well. And then August, you'll put us in touch too with your community lead, so that way we can post more of the training sessions and spread the word on this mission Wells Fargo has to, help people with the technologies that they're doing. So thank you very much for your time, August, and for everybody participating in these Tech Shares, and for the presenters as well. I know you've put a lot of time into this. So thank you very much.
Thank you so much.